Yo, what is good, dev guys? Welcome back to part 3 of this video tutorial series. I actually forgot to add one very important class last episode, so I'm gonna right click in this public folder here. I'm going to add a directory. We're going to call this our core directory, and inside of this directory I want to add another directory, and this is going to be our singleton folder here. This is where we'll put everything that will only be one per class per project. So in here we want to go ahead and add an Unreal class, start off with UObject, and this is going to be our AL_game instance. Now the game instance is where we're going to actually run our async loader. You can do this in other places. Actually, the asset manager handles this for you. But in this project, we're going to use the game instance because we can always get the game instance no matter where we are, whether we're on an actor or UObject. You just have to kind of manipulate the system to get the game instance, but you can always get it. It's a static call, and this is going to inherit from game instance. We can also get rid of this include for UObject. It's already included in game instance. So let's go ahead and start filling out our data assets. So I'm gonna come to our AL part data, and I'm gonna right click on it and close all the other tabs so that we just focus on this in the CPP file. And what we're going to do is we're going to use TMaps. Now TMap is a data type that has a key value and it has a key and a value. So that key points to the value, and you'll see what I mean when we actually type it out. So let's go ahead and create our keys, which we're going to use enum as a key. You can use integers as a key. You can use, I think you can use floats. I don't know why you would use floats. You can use pretty much almost any data type as a key as long as it makes sense. For us, it's going to be an enum. We're going to create a enum. If I could spell enum, and this is going to be called skeletal parts. And I also want to make it a uint8, and we'll go ahead and move these down. And you see I get an error here. It'll say that I'm missing something, and this needs to be a class. And we also need to make this a blueprint type. So now let's fill this with values. And when it comes to a TMap, you want to have a default value that you won't use, because once you have a default value assigned as a key value, you won't be able to add another key. And you'll see what I mean by that in the editor when we compile this. So I'm gonna go ahead and give it a none for our default, and then I'm going to say skeletal part _1, and then I'm gonna copy this by holding shift and home, Control C. I'm gonna paste this a few times, and then I'm going to hold Control Alt and Shift to create. Actually, I don't need to. I'm gonna just delete this, put a 2, and then delete this and put a 3. So this is just being very generic here. You can really have this tie into whatever the part that you're creating this key for is. So if you were creating a gun system and you wanted to have something for like magazines, you would have a light mag here, extended mag here, heavy mag here. It's what I'm doing in my project. And this just acts as a human readable key for you. So let's go ahead and copy this, because we need one for our static meshes as well. And we're going to go ahead and call this static here. And a cool little thing that you can do in Rider, you can probably do this in Visual Studio, is add multiple cursors. So if you hold Control Alt and Shift and click on the line that you want to add a cursor, it'll add a cursor. Then you can just go ahead and delete all of this and type in static and hit escape to get out of that tool. And now that we have our keys, let's go ahead and create our TMaps. And this is a syntax that I recently learned, and I plan on using this wherever I can use it. TMap is a wonderful data type. It also works good when you just need to grab a name from for something like a UI. You can just grab the key value. You don't have to grab the value. You can just grab the key. It's a beautiful data type. So let me just type it out. So property, that's going to be an edit anywhere so that we can manipulate it in the editor. and we're going to put it in a category of skeletal parts. Or let's just call it parts so that we have everything in the same category. And then we're going to go ahead and create our TMap. And the first thing it takes in is a key type, which is our skeletal part. And then the next thing it takes in is a value type, which is the actual object or class type that this key will point to. And we're going to forward declare our class here and call it our UAL underscore skeletal. I believe it's skeletal mesh comp, which is what we call it. You can always double check by control clicking and make sure it takes you to the class. But what I'm going to do is go ahead and copy this up here and just forward declare it up here. That way I don't have to keep typing this class out every time. And this is going to be called our available skeletal parts. Golly. All right, so we got that for our skeletal mesh. And let me go ahead and forward declare my static mesh as well. So I'm gonna copy this and then I'm gonna replace this with static here. And there we go. So now I can copy this here and go ahead and make another TMap that points to our static mesh here. So I'm gonna copy that, put it here, and then I'm gonna replace this skeletal with static. If I could spell today. All right, so we got our TMaps, and these will be used to go ahead and find out what actual asset we want to point to. We need to go ahead and create a few more properties here. So let's go ahead and create a private section because we need to have an array that all of the objects we find will get put into. So I'm gonna go ahead and create a private section. And I just realized that I didn't create a public section here. So everything is actually private. So let me create a public section above these U properties. And under this private section, I want to go ahead and create a T array. And this is going to be a T array of our UAL skeletal mesh. And this is going to be our found skeletal meshes. Or skeletal parts. And then we could copy this here and go ahead and replace this skeletal with our static. Paste this here and then replace this found skeletal parts with found static parts. And this will be an array that we fill by actually calling our async loader and running that logic. It'll get filled that way. We also need a few things as well. We need to create a T array of enums so that we could kind of feed our system the enums that we will actually look for. So this TMap, it will look for an skeletal part type, and we're going to feed that type to it. So let's go ahead and create a protector section here. And in this protector section, we'll go ahead and create a U property, and it's going to be edit anywhere. It's going to be in a category of, it's going to be async loader helpers. Actually, async helper data will be better. And this is the data that will help the async loader. So this is going to be a T array of type skeletal part. And we're going to call this our skeletal parts to find. And we can go ahead and copy this, and you know how it is, baby. You ain't trying to type shit 3-4 times, you know what I'm talking about? You want to type it maybe twice. This is our static part, and let's convert this to static parts to find. All right, so this will be the data that we use to fill in our data table that will get passed into this function that we'll use to dynamically find this part here and load it. Now, I made an error here. I just realized it. I got a hard reference, and it's not even a pointer, which is very stupid of me. So this actually needs to be a soft reference here. So let me type in the code for that. It's called tsoft class pointer. And I'm going to cut this and put it inside of this wrapper here. And I'm going to do the same thing here. It's a tsoft class pointer. I'll cut this and put it here. And this will just give us a hyperlink, so to say, to this actual object. And I also made a mistake down here. This needs to be pointers to our objects so that we can actually get the data from them. I'm going to save that. We need one more TArray here. This TArray is going to hold all of our combined object paths. And this is something that you'll see in action when we actually create the object paths. It's going to hold all the object paths, and then we're going to fill it with all the objects that we loaded so that we can unload them at a later point. So I'm going to go ahead and make a TArray at fsoft object path, and we're going to call this our objects to unload. Alrighty. So we got all of our data. Now we just need to create our functions to actually get the data loaded and get the data when we need to call for it, and actually just do all of the functionality that's needed. So in this protected section, I'm going to go ahead and create a region just to keep these all in one place, and I'm gonna call it my functions here. Now we need a function to async load these available skeletal parts. We need a function to unload them, and we need a function to load these and you see the error here. You see the error in copying and pasting. So this needs to be static part. So we need to load our static part as well, and that's going to require a function. So we need 2 async functions, or async wrapper functions, that we'll actually use in Blueprint. And then we need a getter function that gets the private variables that we created down here. So we need 4 functions, or 5 functions right now. And all of these are going to be U functions. They're going to be Blueprint callable. At least the majority of them will be Blueprint callable. And they'll be in the category of data async unload, or data async helpers. And this will be a load helper. Then we'll have an unload helper. So let me go ahead and create this. It's a void, and it's going to request an async load. And it's going to request an async load of our skeletal parts. And this function needs to take in a const U object pointer. And this will be how we get the world to actually get the game instance. So it'll make sense when we code it. So this is going to be called data owner. And then we can go ahead and copy this, because we need to do the same thing for our static parts. So let's call it static part. And we need a function to unload all of our found parts inside that array. So let's call this our data async unload helper. And this is going to be void unload all objects. And here, and it's not going to return anything. And we do need to also get a reference to the world so that we can get our game instance, which we will actually reach out and call this information on our game instance. All right, so the last 2 functions we need are getters for these 2 parts that will be loaded. So these will both be Blueprint callable. I'm sorry, they'll both be Blueprint pure. So I'm gonna copy this U function and just change it up a bit. So Blueprint, let's call this Blueprint pure. And this is gonna be our data async getters. And let me just put this into my copy buffer. And this is going to return a TArray. it's going to return a TArray of the classes that we're trying to get. So it's going to be a TArray of that UAL underscore skeletal mesh component. It's going to be a pointer. And we're going to call this get available skeletal mesh or skeletal parts. And it's going to be const because we're not going to manipulate any data. We're just going to return data. I can copy and paste this. Make sure I get the name right here. So static mesh comp is what we want to get. And let's go ahead and get rid of this skeletal, call it static. And with that being saved, let's go ahead and create our implementations of everything. Go ahead and get these going and boom. All right. So let's start with the easy ones. This returns a TArray. So let's just return our, what do we call it? I just forgot that fast. We get rid of this. We call it our found skeletal parts. So let's return our found skeletal parts. And here we want to return our found static parts. All right, so that's the easy ones out of the way. These other ones are going to be a little bit more engaging, you know what I mean? So just follow my lead here. We can start with the easiest one out of all of them. So unloading assets will just do a few things. We're gonna get our game instance. And if we have a valid reference of that game instance, we're going to go ahead and run the rest of our code. And this needs to be tabbed in. We need to go ahead and empty both of our arrays to tab. And we also want to run a for loop over our objects to unload array, which should be filled by our request async load functions. We want to run an array over all of the objects, all of the indexes in that array, and remove all of those path names. So it'll be something like iterate over our objects to unload array. And this will be inside of the for loop. And what we want to do is create, whoops, put a comma. We want to create a constant temp variable to hold the name of the object at the array index. And then we want to go ahead and unload that object. All right, so in code, this will be a little bit easier to read in code. So get our game instance. We're going to go ahead and create a pointer to our it's a UAL game instance. We're going to create a pointer to that, and we're going to call it my game instance. And this is going to be equal to a cast to our game instance. And we're going to use our data owner. We're going to get the world that data owner is in, and from the world we can get the game instance since it's a singleton. And that should return our game instance if it's valid. So that gets our game instance. Then we want to check if our game instance is valid. So if it's not valid, we want to go ahead and return out of this code. So let's go if return if, and this is a live template that I have. I've shown in multiple videos how to create live templates. So if not my game instance, go ahead and return out of this code. But if we do have a valid game instance, the first thing we want to do is, I forgot to put this in the pseudocode, and this actually needs to be shift tabbed out. And let me get rid of some of this space, Control X, X, X. And in the pseudocode, we actually want to check and see if we have any data inside that object data to load. So we need to go ahead and say if our object to load array is empty. So let's just say .num is less than or equal to 0. If it's empty, we want to return out of this code. We don't want to do anything. But if not, we need to go ahead and empty both of our arrays. So first things first, let me go get my found, let's do found static parts, and we can call the empty function on it. And this will go ahead and empty out the array. And we can do that for the found skeletal parts too. Dot empty, and that'll go ahead and empty out the array. So we got that done. And now we want to go ahead and iterate over our object to load array. So let's just create a for loop, and I'm gonna call this index. As long as our index is smaller than our object to load.num, we want to go ahead and iterate through. And inside that array, let me bring this code up here. This is here, and inside that array, we want to do these two things here. We want to create a const temp variable. That const temp variable is a const f object, and let me see, it's a f soft object path. And this is the same type as the array. The array is a TArray of f soft object paths. So we need to create a singular version that we could use. So it's a const f soft object path, and it's going to be called path name. And we can go ahead and set it equal to our objects to unload at the index that we are currently at. And once we have that, we want to go ahead and unload our assets. And that is going to require us to get our game instance. And I just realized that we don't have the asset loader available on our game instance. So we need to navigate to our game instance, which is in core singleton. And let's make a public section, shift tab public. And let's go ahead and create that asset loader. It is of type F streamable manager right here, F streamable manager. And if you don't have writer, it's declared an engine / streamable manager.h. And we're going to call this our asset loader. And that's all we need to do in the game instance. We just need to have a version of this somewhere where it'll never get destroyed. So now we can go back to our part data class and go ahead and get that asset loader. And we need to call asset loader.unload. And this unload function takes in a reference to the f soft object path. And I can actually make this the same data type here. So I'm gonna go ahead and set this here, and path name is where it will be used. So this is what we want to unload. We want to unload whatever path name is filled into this variable here. So that is how we unload objects there. So for loading objects, it's the complete opposite. So the first thing we want to do is make sure our available skeletal parts has a value. So make sure, so if our available parts has more than 0 indexes, and we need to make sure that the enum key that we pass in, which is our protected skeletal parts array, we need to make sure this has more indexes or more than 0 indexes as well. So typing pseudocode is sometimes harder than typing code because you have to make it human readable. So if available parts and key arrays have more than 0 indexes. And let me put a check in front of that. Check check if available parts and key arrays have more than 0 indexes. And then what we want to do is go ahead and create an asset path list. And this is a TArray that we will use to kind of temporarily fill with our async loader. So we'll create an asset path list. Then after that, we want to go ahead and iterate over all the incoming part or key names and find the key names inside of our TMaps. So we want to iterate over all incoming key names and then find the value of that key in our TMap. And there's a pretty little function in the TMap that is basically says find. You pass in the key. And once we get that key, we want to add that key, add that found object to both our assets to load array that we created up here, the path list. So add both to our path list and our objects to unload arrays. Because I'll explain it when we type that code. And then once this array is filled, we go ahead and call our game instance to async load that array. All right, so let's go ahead and type this code out. So check if available parts and key arrays have more than 0 indexes. So that's a simple if check. We check if our part available skeletal parts, because we are in skeletal part, .num is greater than 0. And we want to make sure our, I forget the name of that data type, our skeletal parts to find .num is greater than 0. So we want to make sure both of those have more than are not empty arrays. And then if they aren't empty arrays, we want to go ahead and create our asset path, which is inside of here. And all of this code will happen inside of this if array or this if statement here. So let me go ahead and cut it and paste it in here. So our asset path list is a TArray of that F soft object path type. And this is our assets to load. And now we want to iterate over all the incoming names and then find the value of that key in our TMap. So that's a for loop. So we're going to write a for loop. We're going to call this index. And as long as our index is less than our skeletal parts to find, we want to go ahead and move on through that array. So we want to go ahead and create a const. We want to create a singular version of this so that we can pass it in as a key. So we need to create a const e skeletal part, and this is going to be called our part name, and set this equal to our skeletal parts to find at whatever index we are currently at. So, all right. And now that we have that, we can go ahead and pass this key in to our find function, but we need to do a little wrapper here. So we need to add the part that we find to the assets to load. So that follows assets to load dot add unique. And we want to add the available skeletal parts dot find. And let's pass in that part name. And we want to do a couple of things. We want to turn this, once we get it, we want to turn it to a, actually we don't need to get it, I'm sorry. We need to turn this to a soft object path. So this will convert whatever object we find, whatever soft reference we find, and it'll convert it to a soft object path, which is of type F soft object path. So that'll add that unique string to our already created array here. Then we also need to do this same logic to our objects to unload array. So I'm gonna just go ahead and copy that and pass in objects to unload. We're gonna add that same part name to this here. And then once this array is filled, and this is supposed to go here. And once the array is filled, we need to go ahead and tell our asset loader to load our actual objects. So that goes as follows. We need to go ahead and get our asset loader, which is located on our game instance. So we need to go ahead and create a pointer to our UAL_game instance and call it my game instance, and set this equal to our cast. And we need to bring in our UAL game instance, and we need to get our data owner so that we can get the world that it's on and go ahead and get the game instance that's in that world. So that'll return that. Also, we want to always do a null return check. So if that is null, we want to return. We want to go ahead and return, but if it's valid, we want to go ahead and get our game instance, and we want to get that asset loader. And we want to call a request async load. Now this takes in a few parameters. It takes in a you can give it a singular target to load, or you can give it multiples with this TArray. That's what we're going to do. But you also see that here it also binds you to a delegate. So we need to create a function to actually bind the delegate to. So let me create that function in our header class, and we're going to create it inside of our, let's create it inside of our, right outside of our functions here. And this is just going to be a U function. And we need to have that so that we can bind to it. And then we can call this void on skeletal objects or skeletal parts loaded. And this will get fired when that delegate is called. And while we're here, let me go ahead and create the other one for the static parts. So when the static parts are loaded, we want to call, we want to call this function. So I'm gonna Alt insert, create the definitions for that, and hit OK. And now we can go ahead and give this the data it needs. The first thing it needs is the object path. So we're going to give it our assets to load. And then we want to go ahead and create this delegate. So we have to, it's a weird syntax. So you have to go create a f-streamable delegate. And we want to create a U object. And we want to give it this object. And we want to pass an address to our function al underscore on, yeah, there it is, on skeletal parts loaded. So that's the delegate that we want to get fired when this function is, when this assets are loaded in. And that's pretty much how we load every other part here. So what I'm going to do is copy all of this code, and I'm just going to switch out the names. So for request async load static part, we're doing the same code here, all the same code here, but we want to change this to available static parts and static parts to find. And we want to go ahead and change this to static parts to find. And we want to change this to static parts to find as well. And we want to change this to e static part. And then we want to go ahead and change this available skeletal parts to available static parts. Same with this bad boy underneath it. And what's the error here? What's that? Oh, we're missing a bracket. Okay, so what else do we need to change? my game instance. And we need to change this callback function to on static parts loaded. Whoops. So this function will get called whenever our static parts get loaded. And when we actually load those functions, or when these functions actually get called, we want to load our private variables with the data that we got. So let's go to those functions wherever they were created. And in here, we just want to iterate over all the incoming part names and go ahead and find those parts and add the actual objects of those parts to our array. So iterate over those parts, over available skeletal parts, and find the objects of the key name, then add that object to our found part array. So this is a for loop, and we want to call this index. And as long as our index is greater than our skeletal parts to find .num, we want to go ahead and create a const e skeletal part, and we want to call this our part name. It's very similar to how we asynchronously loaded the data. We want to set this to our part name, and we want to set it equal to our skeletal parts to find at the index. And then we want to go ahead and add this to our private array, which is called found skeletal parts. So I'm going to copy this and paste it here. Found skeletal parts dot add unique, and we want to find the object inside of our available skeletal parts. So dot find, and we want to pass in that part name for the key. And here we need to get the object, and then we need to get the default object of it so that it will give us the actual class that we're looking for. And we also need to pass in the type here. So the type is of type I think it's UAL underscore skeletal mesh component. And this will go ahead and give us a object pointer to the type of object that we passed in. It'll give us the blueprint object of this type that we passed in, and it'll be able to fill this array of UAL skeletal mesh pointers with the object that we grab out of here. So we need to do this same logic for the static parts. So let's just change the names here. Static parts to find, copy this, paste it here, and we need to do found static parts, and we need to go ahead and change this to e static part, and this is going to be available static parts, and we need to give it the correct type, UAL underscore static mesh component. Okay. And what else are we need to go ahead, and what else are we missing here? I think we're pretty much good. So what I'm going to do is since we did so much, I'm going to stop the editor and rerun it. So all right, so undefined type UAL static mesh component, which is fine. We just need to include the header, soft static class, overload function found. This is probably having something to do with it not being able to find our class. So we need to come up here and we need to go ahead and hashtag include our parts. So this is in our YT async loading in public, and we need to go to our parts skeletal and this one, and then we need to go ahead. Let's go ahead and copy this, and let's just feed it the other project, the other folder file. So this will be static, and this part here, and then we can just delete all of this here, and there we go. So now if we compile here or run the editor, we shouldn't get that error. There we go. All right, so the last thing we're going to do is just go ahead and set up our data asset. And in the next video, we'll start actually setting up the interface to, actually we'll set up the UI that will require us to set up the interface that will talk to our actor in the world. So as you can see here, we have our parts TMap, we have our async data helper or helper data here. I'm gonna drag this up. I didn't know you can even do that. So what I was saying about the maps, where if you have none selected as the let's say you have none selected as the key here, then you go and try to add another map, it'll give you this error: cannot add a new key of the map while the key with a default value exists. So that's why you need to have this, because if your first value was skeletal part 1, if this was your default value, meaning you didn't have none, you wouldn't be able to add another key until you added all the other keys first and then this one. So always have one that you're not going to use and then have the ones that will be in use. So with that, let's go ahead and create some assets here that we can fill inside of our data asset here. I didn't want to put this in a separate video. It's such a quick step. So let's go to our skeletal classes and let's create a blueprint class that is derived from our UAL underscore skeletal mesh component. And we're going to call this part underscore 1. And then what I'm going to do is just control W to duplicate it, and then control W to duplicate it again. We're not going to make this all crazy and whatnot. I will go ahead and jump into these and add the mesh component here that I want to add. And I didn't import any meshes into this. You can go ahead and do that if you want. I'm just using the engine content. So I'm going to give it this one for the first one. I'm going to jump in here. I'm going to give it the second one for this one here. And I'm going to do this save on compile on success only, so that the object saves if it compiles correctly. And then I want to give it this one here for the last one. Now we can do the same thing with the skeletal mesh, create a blueprint class. Let's use our UAL underscore static mesh component. And let's create this one, and it's going to be called part underscore 1. Duplicate that, and let's jump in here and give it some static meshes. So I'm gonna give it this arcade sphere. I'm gonna go ahead and jump in here and give this a, let's just give it the bounding box corner. And then this last one, we can give it the cone. Sounds cool. All right, so with that, we're going to go ahead and stop this video here. In the next video, we'll work on the UI and setting up the buttons for that. So if you guys are ready for that, go ahead and join me in the next video, and I'll see you guys in there. Peace.